Okay, this recording will cover sections 8.2 and most of section 8.3. And to start off with section 8.2 here, we're going to take a look at some composition of normal trig functions, sine, cosine, tangent, and all that with other inverse trig functions. Last time we were in class, we talked about we talked about problems where we had like the sine of the inverse sine of something, or the cosine of the inverse cosine of something, and so we composed a particular trig function with its inverse. But now what we have is we have kind of a mixture, mix and match of trig functions with other inverse trig functions. So we haven't done anything like that. So we'll do a few of these problems. I'm going to start off with this problem here where it says find the exact value of each expression. And so number 25 down here says to find the tangent of the inverse sine of 1/3. And one of the ways to address this is just to simply take a look inside here and see if we can come up with a way to represent an angle whose sine is 1/3. Remember, what we put into an inverse function is a trig function value. For example, here, if it's inverse sine, this 1/3 is a sine value. And so the inverse sine of that sine value is going to be some angle. But then we're supposed to then take the tangent of that. So ultimately, this outside function is going to dictate our answer here. We're going to find out what is the tangent of whatever angle we would get back from the inverse sine of 1/3. And sometimes, like some of the ones that you see up above here, those are angles that are easy angles to find. They're on the unit circle. But this one here is, we don't have an angle on our unit circle that has a sine value of 1/3. So the easiest thing to do, I think, on this is just to kind of draw up an example of where this angle would be. This inverse sine of 1/3, again, remember it tells us about an angle whose sine is 1/3. The inverse sine gives us angles back that are between pi/2 and negative pi/2. If you remember our range of our inverse sine here says all angles between negative pi/2 and positive pi/2, and if it happens to be in the fourth quadrant, it would be a negative angle, and if it's in the first quadrant, it would be a positive angle. So here, since the sine value is positive 1/3, and since then if we have to choose between the first or the fourth quadrant, since that's the only angles we're going to get back for inverse sine, it must be in the first quadrant. So we go ahead and just draw. I'm going to draw a reference angle and a reference triangle here, and that will represent these sides 1/3. So remember, sine is going to be opposite over hypotenuse. And so this opposite would be 1, hypotenuse would be 3. Okay, and so if we do the Pythagorean theorem to figure out our missing side here, you're going to find out that that is radical 8. And you can just, use the Pythagorean theorem to find that. Or you could say, simplify that to 2 radical 2. Well, once we have that, we've basically represented theta here. And again, that inverse sine of 1/3 gives us this angle theta. And now this triangle represents this angle theta. Now we just need to say, what's the tangent of that? The tangent of that angle. Well, the tangent is opposite over adjacent, right? So we're saying the tangent of this angle theta would be 1 over radical 8, which is, well, let's see here. We can just rationalize that, right? So if we rationalize that, multiply it by radical 8 over radical 8. So that's radical 8 over 8. And this would be 2 radical 2 over 8. So that would simplify to radical 2 over 4. So our answer to this composition of these two trig functions, the tangent of the inverse sine of 1/3 is radical 2 over 4. Again, work with the inside function to draw a reference triangle, and then take the tangent of that angle theta. All right. Let's try this number 14 up here. The cotangent of the inverse sine of -1/2. It's right up here, number 14. That was number 25. And we're doing 14 next, which is the cotangent of the inverse sine. Man, this tablet doesn't work so hot sometimes. Inverse sine of -1/2. All right, and remember, so this, we're saying basically what's the cotangent of some angle, right? Because this inside portion, an inverse trig function gives me back an angle, and then we would be taking the cotangent of whatever that angle is. And again, we don't even have to know what the angle really is. Ultimately, we could simply, even if we didn't recognize it, that it is actually one of the angles on our unit circle. But what if we just sketched up an angle using this inverse sine of -1/2, kind of like we did the first example here. And since the inverse sine of -1/2, remember that gives us angles back in the first or the fourth quadrant, something between -π/2 and π/2. And so that's going to give us an angle back here that would be down in the fourth quadrant because it's negative. A negative sine value, and we only choose between first and fourth quadrant, then that means it's going to be in the fourth quadrant. Here's our reference triangle here. We'll use this as our angle, reference angle. So then opposite over hypotenuse. So hypotenuse would be 2. We're always going to put a positive number for that. -1 for this opposite side here. And then if you do your Pythagorean theorem, you'd figure out this is radical 3. And now they just want to know what's the cotangent of this, right? Well, the cotangent here, the cotangent of this angle theta, of course, that is going to be, a tangent is opposite over adjacent. So this would be adjacent over opposite, right? So that's going to be adjacent to theta here is radical 3. And opposite would be -1. And so that is a value of negative radical 3. So that's the answer to what is the cotangent of the inverse sine of -1/2. Okay, we'll do one more. And this one we're going to do is an example of one of these ones where you can see that some of these problems we have the inverse function on the outside of that composition of two functions, and sometimes the inverse function is on the inside. We haven't done one with the outside, and so we're going to do this number 21 here, the inverse cosine of the sine of 5π/4. So let's try that. That's number 21. All right, so we've got the inverse cosine of the sine of 5π/4. Now with these, remember we've been working from the inside out. So now this one, instead of the inside being an inverse function, it's actually a normal trig function. It's the sine of π/4. So that will be a sine value. And so that being on the unit circle here, I need to pull up okay. All right, so here we go. I just wanted to be able to show it to you rather than just spout off what the sine of 5π/4 is. So here we can see the sine of 5 pi over 4, which is down here at 225. The sine, which is the y-coordinate, is negative radical 2 over 2. So negative radical 2 over 2 is the value of the sine of 5 pi over 4. So we can just simply replace that. We still have the inverse cosine here, but we can replace that with negative radical 2 over 2. Okay? So now we're just left to find what is the inverse cosine of that. And remember, what's getting plugged into an inverse trig function is, in this case, a cosine value. And our answer is going to be an angle. So we're looking for, we can just pop up our unit circle again here. We're looking for an angle. This time, it needs to be in the first or the second quadrant, because remember, the range of our inverse cosine is between 0 and pi. That's a first or second quadrant angle. And so we're looking for an angle in the first or second quadrant whose cosine is negative radical 2 over 2. So we know that's going to be in the second quadrant because it's in the second quadrant that the cosine is negative. And so then, of course, it's going to be over here. Here, our cosine value is negative radical 2 over 2 for 3 pi over 4, or 135 degrees. So this would be equal to 3 pi over 4, or if we're being asked to put it in degrees, it would be 135 degrees. Okay, so those are several examples of how to compose two functions where one is an inverse and one is not an inverse function, but they're mix and match. They're not. It's not like sine and inverse sine and cosine inverse sine and tangent inverse tangent. It's mixing and matching that.